Okay, everyone, let's get going. Uh, Good morning. Welcome back to class. Let's have a look at the calendar. So let's see, it's Thursday. We're going to go through 1.3 and 1.4 today. Keep in mind, exam 2 will open up here in a couple of weeks. I haven't gotten that ready yet for the testing center, so hopefully by Monday or so you'll be able to get registered for that and get a slot at the testing center reserved for you. Are there any questions as we get going with anything? Either from the homework or about how the course is going to work? Anything at all that I can help you guys with? You guys can hear me, right? Let's see here in the chat. Let's see, I've got a chat here. Okay, yeah, you bet. If your mic isn't working, yeah, you can put in questions in the chat. So great. All right. Well, let's get going and just let me know if any questions come to mind as we get started here. So last time we finished talking about types of data, right? So broadly speaking, there's two kinds of data. There's categorical and there's quantitative. And actually, let's just look at our picture here. So there's quantitative and categorical. And then under quantitative, you can break it down further into discrete and continuous. Okay, so what we're going to do now is move into collecting data. This is a really tricky part of stats where we try to get a sample that resembles the population as much as possible. Okay, so let's look at some more definitions here. We have population. So population is the target group that we're interested in. Okay, so when we do a study, we have a group of people that we're interested in, and that's our target group. But typically, not always, but typically, the group is large or it's too large. It's so large that we can't collect data on everybody or everything in the population. Okay, so if you're studying people in Utah, for example, there's 2 or 3 million people. That's really hard to gather data on 2 or 3 million people. And if you're studying people in the US, then there's like 400 million people or so. And so it's really hard to collect data, or maybe impossible, from everybody. So what we do is we take a subset of individuals. Okay, that subset is called the sample. Okay, but this introduces problems because, or this can introduce problems because our sample might not look like the population, right? The sample might be non-representative of the overall population. And if your sample doesn't look like the population, then your results are going to be not so great, right? So that's what the principles of data collection or sampling theory is trying to address, right? We want to make that sample look as much like the population as possible. Okay, so let's talk about these terms here, and then we'll think about how to get the best possible sample. Okay, so this is a diagram I like to use quite a bit for understanding the process of statistics. So we have a circle there. It's like a cloud of dots, and each dot represents somebody in the population, somebody or something, depending on what it is you're studying. Okay, so the population is large, and for the population size, we typically use capital N. Okay, so capital N is the population size. And again, when the population is large, we can't measure everybody, so we choose some people, right? So we might choose that person, we might choose that person, we might choose this person, right? And eventually we get our sample. And the idea with the sample is it's small enough so that we can measure everybody in that sample. So this sample has a size, and typically we use the letter lowercase n for the sample size. Okay, so we actually did this last time, right? If you remember, that informal non-scientific study we did on eye color. There were 14 of us, okay, and 5 out of 14 had the brown eyes, right? So we had 36%. The Harris polling organization said it's 45%, and we got 36%. Okay, so 14 and 36, let's remember those numbers. So our sample size for our study was 14. So from that sample, we got our proportion, right? 36%. Okay, this is known as a statistic. Okay, and so it's a different use of that word. Okay, so we've defined statistics, right, as a science, as the way we collect, analyze, and make inferences from data, right? But statistic singular is a numerical summary of a sample. Okay, so that's our definition here. Statistic singular is a number that summarizes the sample data. Okay. All right. So you might, you definitely have used that word before, statistics, right, in everyday conversation. In the formal, the formal statistics setting, statistic means a numerical summary that's calculated using a sample. Okay. So let's see here. Now, Harris said it was 45%. Nobody really knows because there's not really a data set with eye color for everybody in the country, but let's just assume that that number is correct. Okay, let's just pretend that we actually do know that it's 45%. Okay, so if that is the number that comes from measuring everybody in the country, then that would be called a parameter. Okay, a parameter is a number that describes a population. Okay, so the parameter there, 45%, is a numerical description of a population. So parameter, it's a number, it's a single number that summarizes the population. Okay, so in everyday conversation, people will sometimes say parameter, they'll say statistic, and they might think of them as synonyms. And outside of statistics, they might be, synonymous somewhat. But in statistics, in formal statistics, they are different. Okay. The parameter is a numerical description of a population, whereas statistic is a numerical summary of a sample. Okay. Now, later, we're going to learn how to use this 36% to make an inference about the parameter. So that's what that last arrow there is doing. It's making an inference from a sample to a population. But that's kind of a later discussion. Okay, so we have S in, and another way to remember this is S in sample goes with S in statistics. So S in statistic goes with S in sample, P in parameter goes with P in population. Okay, all right, so the whole goal of 1.3 is to think about how to make that sample look look like the population. Now, we already decided that this was not a good sample. Okay, that it just doesn't represent the actual population of everybody in the country, right? We said it's a somewhat small slice based on age, right? It's a restricted age group. You guys are all most of you guys are living in Utah, right? And so it's not really representative of the entire country. Okay, so how do we make a sample look like a population? Okay, so that's the idea. Well, one way of doing something well is by understanding how things can get messed up. Okay, so we're gonna talk about common ways of messing up samples. What can go wrong when you collect a sample? Okay, and so by studying what can go wrong, we can avoid it, or at least try to avoid it, and get a better sample, right? Or get a better sampling process. So what do we want to avoid? First thing we want to avoid is anecdotal evidence. Okay, so anecdotal evidence is a haphazard way to collect data where the observational units are probably not actually representative of the population. So our study that we did last time with our class, right, was actually anecdotal evidence, right? We just sort of, I just took 14 people that were all in this class and we used our numbers, right? Another example would be to go online to, maybe like uh, a subgroup on Reddit or Twitter or something, and use that as a way of understanding the whole population. Right? It just doesn't work because it's just a subset of the population. Right? Okay, so that's anecdotal evidence, and so so an example would be again like Reddit. Okay, it's good for getting information, but it's not really representative of the whole population, right? Or maybe like Twitter or something like that. So these are examples of anecdotal evidence. Okay, so in other words, it's someone said, right? So someone said this, and that's not a good way of getting a representative sample. Okay, so what makes a representative sample representative? Well, we want to avoid bias. Bias is not a good thing, right? It's bias occurs when a sample is skewed towards some particular interest or subgroup within the population, and it makes it not representative of the population. So we want to avoid bias, right? And so how do we do that? Well, by studying the three kinds of bias. Okay, so there's three different types of bias. And there are more actually, but these are kind of the three main ones that we're going to focus in on in this class. So the first is called sampling bias. Okay, and that's when the method that's used is a poor method. Okay, and so I like to say that this will get you fired. Okay, so if you are an analyst, a data analyst, somebody, collecting the sample, if you use a bad sampling method, then that means you're bad at your job, right? Okay, so this is something that you can avoid, right? And you have control over this, right? So so how do you get sampling bias? What are these bad methods? Well, the first poor method is called the convenience sample. Okay, so convenience usually sounds pretty good, but in this context, it's kind of being lazy, basically. So when you're doing a convenience sample, you're basically just kind of uh, assembling a group of people that are easy for you to talk to. Maybe they're in your family or your friends, or maybe they're in your network on social media or something like that. This is called a convenience sample, and it's where you're talking to easily accessible individuals. Okay, and this is actually exactly what we did last time in class, right? We were looking at eye color, and I did a convenience sample. You guys were all here, and it was really easy for me to grab that data from you, right? And it was not representative. So that's a convenience sample, and we want to avoid those if possible. Okay? It's not always possible to avoid convenience samples. For example, if you're doing like historical research, you're kind of stuck with whatever data you can find, right? So I'm not saying we never do convenience samples, but if we can avoid them, we try to avoid them. Okay. The other kind of poor sampling method is the voluntary response sample. Okay. So the voluntary response sample is another non-representative sample where individuals choose themselves whether or not to be included in the sample. Okay. So what I mean by this is the people are actually kind of seeking out, or they're in a position where they're sort of seeking out polls and other opinion surveys, basically. So what am I talking about? Well, people who are on the internet and maybe on like social media. I'm sure you've seen this before if you're on social media, where again, it's like Reddit or Twitter, and a poll will pop up, right? And it'll ask you questions about, how you feel about this or that social issue or celebrity or something like that, right? And the reason it's not representative is because you're probably seeing that poll because you're already kind of interested in that topic, right? Or you kind of have a certain opinion about it, right? And so by being in that group, and maybe not everybody has the same exact opinion, but there is definitely, kind of a directional bias there, right? And so anything on the internet where it's a poll that pops up, these are going to be voluntary response, okay? Because the people weren't randomly selected to be in the poll. They're just there and they're already on the website, and it pops up and they take the poll, something like that. Or maybe like this might is a little bit older, but like you listen to the radio and they ask people to call in and give their opinion about it, right? They still do that. Well, who calls into the radio, a radio program when they ask for people's opinions? Well, it's people who kind of agree, right, typically with the person doing the program, right? And it's typically people with strong opinions about it. And so it just creates all kinds of bias issues with the sample. Okay. So these are things that you can avoid typically. And so I would say if you're doing a convenience sample or you're using a voluntary response sample, then it's just bad practice, right? The other two kinds of bias, let's see, I got something in the chat here. I missed this. Let's see here. Laura has a question. So would work/company surveys fall into the last bias? Probably. So, sometimes it can be really difficult to assemble data, and it still can be useful to think about data that comes from a poor sampling process, but you just have to be aware of the fact that it's probably going to be biased. Okay, so now you can get a good work company survey, and let me give you an example. It would tend to work better at, say, a large organization with hundreds or thousands of employees. So if you work for, say, Walmart, right? Maybe you're an accountant at Walmart or something like that, or sorry, a data analyst at Walmart, and you want to collect a sample about, you know, opinions, work conditions, right? Then yeah, I mean, you probably could get a nice long list of people that work for that large organization and randomly sample those people, right? And in that case, that would be fine. Okay, so but maybe for like smaller companies, it'd be a little bit harder to do that kind of survey. Yeah, good. So you probably would start to have problems with the voluntary response. Okay, so again, the voluntary response, that just means that the people themselves are choosing to be in the survey. Good. All right. So the second type of bias and the third, these aren't exactly your fault. Okay? These kind of happen, and they can be difficult for you to control for these last two things. So what is the non-response bias? This is when too many people refuse to provide information and it becomes unclear whether the respondents are actually a good representation of the population. Let me give you an example. This would be especially the case for kind of sensitive questions, sensitive topics. So let's say we have our population here, and let's say we're doing research about substance abuse. Okay, so you're trying to figure out maybe some question about people's opinions or experience with substance abuse issues. And in the population, there are going to be people who've had problems maybe with substance abuse, right? And then there's going to be people in the population who have not had substance abuse problems. Okay, so if you just randomly start calling people, what might happen, right? So you call people and you ask them about, their current drug use, right? Tell me about your current illegal or illicit drug use, right? What's going to happen? Well, people in here, right, are probably going to be more open about it, right? Because they don't use illicit drugs, right? And so they're probably going to be okay talking about it, right? They say, no, I don't use illicit drugs and I haven't had any problems with it. And what's going to happen is you're going to tend to get more people in here because what happens when you call people that are in the other category? Well, some people will respond and some people will participate and be truthful, but you're probably going to get more, more people kind of hanging up on you, right? Does that make sense? They just don't want to talk about it, maybe, maybe they're suspicious about why people are calling them about it. And so you'll tend to oversample in here and undersample over there. Okay, so in your sample, what you do is you tend to get a lot more in the one group and fewer in the other. Does that make sense? And so this is called non-response, and it's when people who have some characteristic, shared characteristic, tend to respond at a less rate, at a less common rate. Okay, does that make sense? So it creates a bias in your sample. You'll tend to get more people without the substance abuse problems and fewer than with the problems. Okay, so that's just one example, but for any sort of thing with sensitive data, sensitive issues, that would actually probably occur fairly regularly. Okay, so that's called non-response bias, and it's not exactly the researcher's fault, right? Now there are things you can do to mitigate this and reduce the bias, and that's why we're studying this, right? So we can think about like a design, right, for our sample that would take this into consideration. So what could you do? Well, one possibility is to oversample um, in the group that has a lower response rate. Okay, good. Um, let's keep going. So we've got our sampling bias, our non-response bias, and then the third type of bias is the response bias. Okay, and this occurs when people provide inaccurate information. So why would that happen? Well, there's a ton of reasons why response bias can occur. Okay, so um, some of them are more subtle. Okay, so you get an interviewer, they call you, and maybe they're not very professional, or maybe they are professional, right? And the way they ask you questions, they might tend to lead you to one answer or another, right? So their mannerisms, the tone of their voice, this has been studied, and they've shown that this can actually affect how people respond, and it can introduce bias. Okay, so that's pretty subtle. Um, Other things are a little bit less subtle. People can lie to you. Okay, right? So especially if you're asking them about sensitive topics, things that might be embarrassing to them, or if they feel strong pressure to like they should answer in one way or the other, they might just lie, right? And so again, that's not, it's not exactly the researcher's fault. So there's things you can do to reduce this, but again, this is just the nature of how sampling works. Um, Sometimes people forget. Okay, so I mean that just kind of happens, right? If you're asking about events that have happened in the past, sometimes people just forget, some details about the past, and might misremember things, and these are all examples of response bias because this is what happens when you get inaccurate information. Okay, so the list goes on and on for response bias. Another one is data entry error. Okay, so sometimes these polling organizations they need people to walk door to door, and most of the people they hire are probably quite good and professional and they're trained, but it's possible occasionally you get some people that aren't trained super well doing this, or maybe they're volunteering and they're just not very good at data entry for whatever reason. They make mistakes, they type in the wrong number. It really can happen quite a bit. Okay, so it's a practical kind of uh, you know sort of mundane thing that happens with surveying. Okay, so this is another example of response bias. And again, it's just what happens when you have inaccurate information. Okay, great. So, any questions there about that? So I'd like you guys to try some of these. And so there are five. Yep, five on here. It's kind of hard to display all of them on the page. So I'm going to put a few of these on here. The last one's going to get cut off. And then I'm going to, again, we don't really have time for everybody to do every one. So I'm just going to assign people to do various ones. So Alexia, can you do A? Armand, can you do B? Brock, C? Carlina, D? Crystal, E? Devin, A? Jennifer, B? Julia, C? Kylie, D? Laura, E? Lindsay, A? Makina, B? Polly, C? Sarai, Sarah, D? And then Shoshana, E? And Sithamini, if you could do E. Okay. And if you prefer, you can just do any one you want. Okay. So just pick one and try it. So we have 5 different scenarios for surveying, and each one has a kind of bias. Okay. And I want you to identify that kind of bias. So read your scenario and write down what type of bias you think it has. And by the way, you can have multiple kinds of biases that happens. So I'll go quiet here for a couple minutes and let you guys consider your scenario. And then if you want, you can do other ones, it's fine, but do at least one there and then we'll talk about it, okay? And I'll go quiet for a couple minutes. And if you want to put your answer over in the chat, that'd be great. Laura's got B for us. All right, so who did A? Can somebody do A for us here? So let's see, we got a retail manager. They want to conduct a study regarding the shopping habits of his customers. He selects the first 60 customers who enter his store on a Saturday morning. Lindsay's saying A is a sampling bias. Yes, that is correct. Alexia, this is a sampling bias. Okay, so again, what's a sampling bias? That's what happens when the method that you use, so it's an error in the method, right? So it's the sample itself makes itself, the method makes the sample not representative of the population, right? This is a convenience sample. Okay, so what is the method? It's a convenience sample, right? This person got a little bit lazy and one morning they just selected the first 60 customers who come into the store, right? It's kind of easy. Just do it one time and get it done and not too bad, right? And, honestly, it probably wouldn't be an awful survey. It probably wouldn't be too bad, but you can imagine, maybe people who do their shopping on a Saturday morning, they might have some shared characteristics. Uh, some kind of bias there, but certainly it's a convenient sample. Okay, so we would want to avoid that kind of technique. So that's sampling bias. Great. Okay. So then B, let's see here. I think a couple of you guys were saying response bias, and yes, I agree with that. That would be response bias. So what's response bias? That's when the information you're getting is inaccurate, right? So why would that be? Well, people are probably going to lie about that, right? Or at least some people would. Some people would probably be open about it. But so let's read it. So a magazine is conducting a study on infidelity in marriage. The editor randomly selects 400 married couples and asks, how many times have you cheated on your spouse? And so, yeah, a lot of people are, just not going to be truthful about that, right? So this would be response bias. Anybody see anything else with this one? For B, it's both response bias and probably, anybody say non-response bias here? I'm not seeing any. Oh, okay, yeah, I think Brock is saying that that's also a non-response bias. So yeah, so it's just like what we were saying with the example over here with the substance abuse problems. Let's say instead of substance abuse, we have infidelity in marriage, right? So let's see here. So again, in the population, there are couples that have had infidelity, and then there's couples that have not had infidelity, right? So what's going to happen when you start calling up people? Well, the people over in this group are probably going to respond at a higher rate than people over in here, right? Um, uh, so people over here, they don't probably have a big problem with saying no. We haven't had infidelity, so you tend to get a lot more over here. And then people over here, a lot of them are just not going to respond, right? Because it's awkward, it's weird, and there's stigma attached to it, right? And so you'll get some people responding, but it's going to be a much smaller rate. Okay. Good. So that'd be both, I think, response and non-response bias. Okay, and then so for C, we have so the police department, they're trying to figure out public's opinion. Yeah, I wouldn't be honest either, probably with that. Um, oh, okay, yep, yeah, for C. So yeah, C is actually pretty similar. It's probably both actually on this one too. So you get a uniformed police officer going door to door, asking questions, right? How satisfied are you with the police department, right? So sometimes a kind of a slightly cartoonish example helps to get the idea across, right? I doubt there's been too many samples done like this, but it's kind of exaggerating it a little bit here helps to get the idea across. Most people, myself included, probably feel a little bit uneasy when they see a police officer come to the door. Um, and so when they ask you how satisfied you are, some people would be honest and give an honest opinion, but I think most people, or at least I would probably tend to overstate, my satisfaction level, right? So it would also probably be a response bias. Um, People are probably gonna just lie a little bit, maybe kind of a slight lie, maybe a big lie. Who knows, right? It's okay, Polly. Good. So D, we have Cold Stone Creamery. They're opening a new store. So of course, before you open a new store, you do some kind of market research. And so they want to know the percentage of households that regularly visit an ice cream shop. And so they get a questionnaire. How often do you go out to ice cream? Of the 150 questionnaires, 4 are returned. Did anybody do that one? I'm looking in the chat over here. Sarai is saying non-response. Yeah, I'd probably go with non-response on that one. It's such a low response level. Okay, and then E, a candidate for governor is interested in how our constituents feel about a proposed increase to taxes on food. So then there's a survey on our Facebook page that asks, do you support a small increase in the food tax, or would you like to keep it at its outdated level so that our state becomes indebted? Okay. What do you guys say on this one? I'm looking for E over here. Did anybody get E? And you can say it out loud too. The chat's great. Or just speaking out loud is good too. Did anybody do E? Sampling bias? Yeah, I think it's a sampling bias. What kind of sampling bias? So sampling bias is the bias, right? It's when you use a poor method. So what's the bad method here? It's a voluntary response, right? Good. Okay, so have you guys ever been to the governor's Facebook page? I haven't, okay? But some people do. Who goes to the governor's Facebook page? Well, typically people who are, really interested in, state level politics, right? Um, and so probably most of the people there are, fans of the governor. So, they would tend to be, on the same page as the governor. You'd probably get a few people who are, strongly opposed to the governor that visiting the web page, but the vast majority of people, who are kind of maybe in the middle or uninterested aren't going to be there at Facebook, right, at that particular page. So this is a voluntary response, and it's leading to a kind of sampling bias, okay, and probably also a response bias. Uh, this is this is kind of a silly question to ask, right? Using all of these weird words like outdated level and indebted, so it might not recover, right? It's just a silly uh, survey, right? But these are actually done all the time by kind of um, partisan groups that aren't really, you know, focused on truth, right? So that would definitely be a sampling bias caused by the voluntary response, and probably also response bias because the wording here is leading people in a certain direction, right? So the wording of questions, the way a question's worded, can kind of steer people toward one answer or the other. Great. So there we go. That is 1.3. Are there any questions about 1.3? Uh, a tip here for you guys. On the midterms, you're going to be able to have a formula card. And so you can have one, printer paper, 8.5 by 11-inch piece of paper with you, and you can put anything you want on there. And so for this first exam, what I would do with these biases, they all sound very similar, and it can be difficult to remember the different kinds of bias. So if I were you, I would, if you know how to use one of these cut and paste tools, I would just make a little screenshot of your notes, and then you go in there, you cut and paste it into a Word document, and then you can print that off and take it to the exam, right? So there you go. Might want to do that, or maybe write down maybe like a screenshot from the homework or something. Anyway, it's just an idea about the formula card uh, for the exam in a couple weeks. Okay, so let's see. We're supposed to do 1.4 today. Let's go ahead and get into that. So in 1.3, we're talking about collecting data, sampling, and we're thinking about things to avoid. What do we not want to do, right? Well, in 1.4, we talk about what we do want to do, okay? And so we're going to learn about the typical sampling methods here. Okay, so some definitions. This first definition is observational study. So an observational study is a way of collecting the data that doesn't directly interfere with the observational units. Okay, so when you observe, it has that connotation of being kind of passive and not really like intervening, right? Okay, so when you're observing, you're just kind of watching, and typically you're not trying to intervene, right? And so with an observational study, you're out there looking, and you're seeing what's going on, right? And you're taking information down. Um, so that's one of our main types of studies that we do. Okay, so there's basically two types of studies. Roughly speaking, in statistics, generally speaking, there are observational studies. And there are experiments. Okay, so an observational study, that would be like, conducting one of these polls about voting, right? So you call people and ask, hey, who are you going to vote for? That's observational because you're not, you're not like trying to convince them or anything. You're just trying to see what's going on with them, right? An experiment is where you actually intervene and you change something about that person or that observational unit. We're going to talk more about experiments later, okay, in a later chapter, in chapter 4. Okay, so that's what an observational study is. There's two major types of observational studies. There's the prospective study and the retrospective study. Retrospective, well, retro means old, right? And so with the retrospective study, you're looking back in time and collecting data about events that have already taken place. Okay, so you'd call people, or you'd have, if you're doing a medical study, you would interview people and ask them about events that have happened to them in the past, their medical history. Okay, prospective means that you are collecting data as events unfold. So if you're doing a medical prospective observational study, you would have volunteers come in, right? And you would interview them, and maybe in a year or two, you'd have them come back in, you'd interview them again, and just kind of see what's happening in their lives, right? So prospective means to go forward with the data collection as events unfold. Retrospective means you're looking at kind of historical kind of data. Okay. So how do we do it? What are the technical methods, right, that we use for collecting samples? Well, there's basically 5 of them that we talk about in here. Okay, there's the simple random sample, there's the stratified random sample, there's the cluster sample, there's the multi-stage sample, and there's the systematic sample. Okay, and I was really happy with the way the pictures came out here with this, turned out with this textbook that we put together, that we edited and helped to assemble. I think the pictures are almost more valuable than the words for the definitions. Nevertheless, let's go ahead and read the definitions. So a simple random sample, it's a way of selecting a sample such that each observational unit in the population has an equal chance of being included. Another way of saying that is every possible sample of a given size is equally likely to be selected. Okay, so what does that mean? Well, what is this box here? This is basically our population. So we have a bunch of blue dots, and each dot is a person or an observational unit. And then notice that some of the dots are red. So those are the ones that have been selected. And notice it's just sort of randomly distributed across the entire population. Okay, so this is the simple random sample, and we abbreviate that SRS. Okay, so it's a very common way of doing sampling. The only catch is you have to know who's in the population. So you have to have a list of everybody in the population. And that's not always possible, right? We don't have a list of everybody who lives in Salt Lake City. Maybe somewhere there's a list like that, but not really, right? And definitely we don't have a list of everybody who lives in Utah or the US, right? It's just, that's really hard to assemble, right? But sometimes we do have a list. For example, I have a list of everybody in this class, right? It's right here. Okay, so let's do some samples using us. Okay, and I'll include me in here as well. And we'll put together a simple random sample. So let's say we're randomly, let's say our population is everybody in this class. We're really interested in the people of this class, right? Okay, so let's say our population is everybody in this class, and we want to do a simple random sample for this class. Now, in with a real study, typically your population is going to be very large, right, in the hundreds or millions or even billions. Here we have a very small population of 23 people. So with a population of 23, typically you wouldn't actually use a sample at all. You would just talk to everybody, right? So we're going to imagine that uh, this is a slightly different kind of scenario here, right? So what kind of sample size would we like to get? How about we get 4? Okay, we could do more, but it's just going to take a lot of time here. So 4 should get the idea across here for us. Okay, so let's do a sample of size 4 using this simple random sample method. Okay, so I've got a list and everybody has a number. Okay, notice we have numbers over here. I might have to change this list a little bit. So let me go ahead and assign numbers over here. Okay. And so what am I going to do? Well, I've got to choose 4 people. So how do we do that? Well, here's how we don't do it. We don't just look at the list and try to get a random list, a random selection. That's impossible. Okay, if you're just choosing people or numbers, it's not going to be random. Okay, if you're choosing people, then probably what's going to happen is you're going to choose your friends. Okay, and if you're choosing from people who you don't know, you're probably going to choose people who look nice, right? Okay, who look like they might participate, right? You're not going to talk to people who are kind of off-putting, right? So that can introduce biases. And the other thing is if you're selecting numbers, it's been proven that humans have favorite numbers. Okay, I'm not making that up. If I were to ask you guys to choose a set of random numbers, we would see patterns in your selections. Seriously, it's true. It happens. So what do we need to use? We need to use a random number generator. Okay, so what are those? Well, there's tables of numbers that have been generated randomly, so you can use a random number table. But we live in an age of free and easy to access software. So nowadays we just use software, okay, to do random number generation. So I also want to use this as a chance to introduce our software that we're going to use this semester. Okay, this is called GeoGebra, and it does basically everything we need for this class, for an intro stats class, and it's free. Okay, so it's free, it does everything we need, and it works pretty well. There's some more expensive software out there that might be a little bit better, but this one does everything we need, and it's widespread, so we like it, and so we built this into our class. Okay, so how do you access it? Well, there's lots of ways of accessing GeoGebra. One way is to go to GeoGebra's website. So let's see, where that be? GeoGebra.org, and you can download their software. Okay, and they have lots of different kinds of softwares out there. They have all these different calculators. So they have a suite of calculators. They have a graphing calculator you can use right here, and you can download these. Okay, but there's one calculator we use that I use exclusively for this class, and it's this one right here. Okay, it's a website. So I don't even download GeoGebra on my computer anymore. I just use the website every time. And honestly, you should too. Okay, and well, depending on your device that you use, you might want to download it. But I always like using this website. Okay, so if you're using the GeoGebra website, make sure it says classic in the URL. So if you look over in the chat, I've put that URL in the chat. So it says classic in it. And this is the one that's the easiest to use, and that's the one I use exclusively in class. Okay, so if you click on that link in the URL in the chat, it'll take you to this website here. And another thing you might want to consider is to bookmark it. Okay, so you see that little star. I'm using Chrome. Everyone's a little bit different, but here that means I've bookmarked GeoGebra. And if you look right up here at the top of my browser, all I have to do is click on this, and it opens up GeoGebra every time. It's because I use it, all the time. Okay, so we're going to use this GeoGebra software to generate a random sample for us. Okay, so all right. So here's the thing. Maybe some of you can pull up GeoGebra now and use it. Maybe some of you can't. If you can't get GeoGebra to work today, don't worry too much about it. Just kind of kick back and watch me do this. Try to get the idea of what different kinds of surveys are, the different random samples are. If you can't get GeoGebra to work today, you're not going to be like in a big it's not going to be a big problem for you. In fact, we're hardly going to use this aspect of GeoGebra this semester. Okay, so what I want you to get out of class today is the idea of the different kinds of methods. Okay, but if you want, you can try to use GeoGebra along with me. Okay, so how to use GeoGebra to get the random sample? We're going to click over here in this box, and we're going to say RAC equals random. Okay, and what we're looking for is this random between. Okay, so I'm going to go random, and you can see it popping up there, random between. So if you just click on it, it'll open up the different possible commands. And we want random between a minimum integer and a maximum integer. What's an integer? An integer is a whole number. Okay, so what random numbers do we want? Well, how many people are in our list? 23, right? So I want random between 1 and 23. I don't know why I lost the between there. Okay, so I want random between 1 and 23. So when I hit the enter button here, it's going to give me a random number. Okay, it's going to randomly select it between 1 and 23. So if you're interested in random number generation, that's a fascinating topic that mathematicians and statisticians have worked together on over the decades. And there's lots of good algorithms in software for this. So I'm going to hit enter, and we have our first person that's going to be in our sample. Okay, so let me make this a little bit smaller. So who's 16? Jennifer. Is Jennifer here today? Jennifer, are you here? Yeah, looks like Jennifer's here, huh? Okay, great. So Jennifer, you are the first person in our sample. Okay, so here we go. First person, Jennifer. Great. So we want 4 people, so we go back to GeoGebra, and I'm going to come over here. I'm going to hit enter again, and now we have 3. Person 3 is Armand. Okay, and I believe Armand is here. Yep. Okay, so Armand is here. Armand, you are in our first sample there, a simple random sample. Okay, and we just keep going until we get 4 people. So come back over here. I'm going to hit enter again. 13. 13 is Julia Grimsley. Looks like you're here. Great. So Julia, and then we do it again. So I'm going to come over here. I'm going to hit enter. Number 4, Haley. Haley, are you here? I'm not seeing Haley. You here, Haley? So what do we do? Well, Haley's not here, so we just go back and ask for another number. Okay, whoops. So I'm going to come over here. I'm going to hit enter. 18. 18 is Anjali. I don't think Anjali is here. Hopefully I'm wrong. Anjali, are you here? No? Okay. Well, this happens. No worries. We're just going to come back and do another one. Number 2, Shoshana is here, I believe, huh? Yep. Okay. So Shoshana, and we've got our sample. Okay. So this is an unbiased process because if I were to sit down and choose people, who knows, maybe I have favorites, right? And I might tend to choose my favorites, right? I don't have favorites, but maybe I would, right? So anyway, this gives us a nice unbiased process for collecting a sample. Good. So we have a good chance that this sample will be representative of our whole population here. Good. Any questions there about that? Okay, so that's a very common method. It's a very good method typically, but there's other methods. The next one is called the stratified random sample. Okay, so what's that? It's a sampling strategy where the population is divided into groups of similar observational units. These groups are called strata, and each one is a stratum. Okay, so then individuals are selected using a second sampling method from each stratum. Okay. All right. So what is a stratum? A stratum is a subgroup in the population. So strata are, that's plural for stratum, and it's where you have, subgroups that are non-overlapping in the population. So what would an example of various strata be? Well, nation of origin, right? Most of us are from one country, right? You're from the US or you're from Canada or something like that. Um, and so they're non-overlapping groups. Okay, so we could do that for our strata. Um, what other kinds of strata are there out there? Any ideas? What do you guys think? What other kinds of strata might there be? Okay, let's see here in the chat. Yeah, maybe religious membership, right? Um, so right, yeah, great. That's very common. And this is a very commonly studied thing by various organizations. So yeah, you've got various religions, and another category for not religious, right? And so people do tend to be one or the other, right? I mean, I suppose you could be a member of two different religions at the same time. It happens, I guess, but typically most people are going to be in one group or the other. Polly's saying zip codes. That's a very good one, right? I mean, typically you live in one place unless you have multiple houses, but yeah, most people are going to be living in one zip code. Great. So for our class, what I've found is that, so let's see, what other ones are there? A common one is politics, so political affiliation, right? So, um, so by far the most common groups are the Republican Party, the Democratic Party, and then there's lots of other parties out there. We could spend all day listing these, so I'm going to just group everybody else into independents. So this might be everybody in the US, right? So, most people are in one of these groups, and most people are not Republicans and Democrats at the same time, right? So you can change as time goes on, but most people are not in more than one, right? So with the stratified random sample, what we do is we have these non-overlapping groups, and then within each group, we'll take some kind of random sample, probably a simple random sample in each of these groups. Okay. So let's do that in our class. Okay. And so I don't want to ask people their political affiliation. That would be awkward. So what I found for this class is a good stratification is um, born in Utah versus not born in Utah. I usually get about half and half about half of the students typically are born in Utah, and about half, like myself, are not born in Utah. So if you're willing to participate, in the chat, I'd like you to say Utah if you were born in Utah, and not Utah if you were not born in Utah. Okay, so just go ahead and type that into the chat, and I need people to participate. Well, if you don't want to participate, that's okay, but it works better if we get more data points in here. Okay, so it takes a little time to assemble this here in class, but it's not that hard. So keep it coming with the information here. I'm going to put that over here. So we'll have a NU for not Utah. Shoshana. Um, Okay, almost done here. Thank you for your patience. Okay, so look over there in that spreadsheet I just kind of altered there. And if I got your information wrong, let me know. And so the blanks are people who um, aren't here today. So let me rearrange this just a little bit to make this easier for sampling. Um, so just do a couple things here. We're not really going to be using Excel in this class very much, so don't worry if you're not good with Excel. You don't need to use Excel at all, really. So I'm just going to, oh, okay, let me put my name in here as well. So I'm not Utah. Let me put myself in here. Okay. So I'm just going to delete these other names. Okay, here we go. So do you see the two strata? Okay, so we have Utah and not Utah. And so we need to renumber these. And so let's see here. There we go. So we have 8 people that were not in Utah. And then it looks like we've got 8 people that are born in Utah. So pretty much like I've been saying, it's about half and half. Okay. So now what are we trying to do? We're trying to get a stratified sample. And let's just stick with 4 if we can. So what does that mean? Well, I'm going to probably get 2 from Utah and 2 from not Utah, right? So, so the picture now is here's our population. The first stratum is born in Utah. Second stratum is not born in Utah, right? So we're going to use a simple random sample to get 2 people there, and a simple random sample to get 2 people there. Does this make sense? Okay, so we need a random number generator. Well, that's what GeoGebra is going to do for us. Okay, so we're going to go random between. Now instead of 23, we're going to be going between 1 and 8, right? So let's do the Utah folks first. So I'm going to get a number between 1 and 8. So I'm going to hit enter, and I get the first person from the Utah group, right? So who is that? That is Shoshana. Okay, so Shoshana is number 1 in the Utah group, right? So Shoshana is again in our sample again. Okay. Then we need a second person who was born in Utah. So I'm going to come back in here. I'm going to go between 1 and 8, and we go 7. So who is 7 from Utah? That is Jennifer. Okay, so Jennifer is also in our second sample. Okay, so that's the Utah folks. What about the not Utah folks? Well, we also have 8 of those, and we need to randomly select 2 people from there, right? So we're going to select, again, random numbers between 1 and 8. Okay, so we hit enter, we get 5. So 5 from the not Utah group is Crystal. Okay, so Crystal, any questions here about how this works? It's not terribly complicated. So 7 there from the not Utah group is Brock. We have second valid randomly selected sample. Okay, and again, the major principle is randomness, right? If you're not using randomness, then your process is probably going to have some kind of bias to it. Okay, any questions? I can go back through that. Is that relatively clear for everybody? If you're a little bit unsure about how to use the GeoGebra, don't worry. But the idea is we have these strata, and we're randomly selecting from each stratum. Okay, the third type is called the cluster sample. And let's look at the picture here. I forgot to mention the picture. So with the stratified random sample, we have these strata, right? So they're non-overlapping. Sometimes one group's a little bit bigger or a lot bigger than the other. And then if you look at the picture, within each stratum, some are selected, right? So we have a few red ones there. We have a few red ones in here. That's the idea behind the stratified random sample, okay? With the cluster sample, it kind of superficially resembles the stratified random sample. we have these groups. So we have cluster 1, we have cluster 2, we have cluster 3, cluster 4. So they kind of look like strata, but look at the color of the dots in each cluster. In cluster 1, none of them have been selected. In cluster 3, none of them have been selected. In cluster 4, all of them have been selected. So where does the randomness come in? Well, with the cluster sample, it's a sampling method where observations are in groups with a lot of variability, and entire clusters are randomly selected and then combined to create the sample. Okay, so the randomness comes in at the cluster level. We're going to randomly select some of the clusters, and then we take everybody in that cluster and put them in the random sample. Okay, so why would we do that? Well, door-to-door canvassing is often done using a cluster sample. Okay, so think about if you are canvassing a city, right? So maybe you're a volunteer for a political organization, right? And you've got to maybe 1,000 people in the city. So what would you do if it was a simple random sample? You would get 1,000 addresses randomly selected, and you would drive to each house, right? So you would come over here, and you would talk to them. Then you would get in your car, you'd drive here, you'd talk to them, you'd drive over here. That's a lot of driving. So with the cluster sample, what you do is you divide the city into smaller groups. So what might a smaller group be? Well, neighborhoods, right? So you got the city and you divide it into neighborhoods. Then you use a random number generator to select certain neighborhoods, right? So maybe this neighborhood's selected, this neighborhood's selected, this neighborhood's randomly selected. Then you get in your car and you just drive to 3 different neighborhoods. You drive here and you talk to everybody in this neighborhood. Then you get back in your car, you drive over here, you talk to everybody in this neighborhood, right? You're out on foot walking from house to house. Then when you're done with that neighborhood, you get in your car, or maybe it's the next day, and you drive over to the last neighborhood and you talk to everybody in that neighborhood. It's still randomly selected, so it's still a valid scientific sample. Okay, does that make sense? So this is the cluster sample. And again, these pictures, I think they just really explain the idea quite well. So I was very happy with how those pictures turned out. Okay, in our class, especially in a Zoom class, it's kind of hard to do a cluster sample. So we're not going to do one in here. The multi-stage is where you have randomness coming in at several places, or 2 or more places, 2 or more stages. So it kind of looks like a cluster sample. You have these non-overlapping groups, and only some of them have been selected. So this one's been selected, this one's been selected, and this one's been selected randomly. So it kind of looks like a cluster sample, but then look at each subgroup. Not everybody in each subgroup has been selected. We randomly select this one, and this one. We randomly select this one, and this one. So randomness is introduced at 2 stages. The Census Bureau, the US Census Bureau, that's the government organization that conducts the survey, the census every 4 years. They use a lot of these multi-stage sampling techniques because it's such a large population. Okay. All right. And then the final sampling technique is the systematic sample. Okay. So these words, are kind of similar, right? I mean, it all sounds systematic, right? So in the context of statistics, though, and especially in sampling, we mean something very precise by systematic. So what does it mean? Well, look at the picture here. We have basically people lined up in a row, and we're randomly selecting every 5th person in the row, right? So we get the 1st person, the 6th person, it's every 5th person, right? Okay. And that's the idea behind the systematic sample. We're going to select every 4th person or every 10th person. It depends on 2 things, the size of the population and the size of the desired sample. So let's do that. Let's get you guys lined up and randomly select 4 of you. Okay, so you're already kind of lined up here, aren't you? Yeah, you're already in a line. in a digital line here. So we're going to randomly select 4 of you. So how many do we do? Well, there's 16 of us in here remaining. So that's our population that we're looking at. We want, let's say, 4. So I'm going to take 16 and divide it by 4. That's going to give me 4. Okay, so we want to select every 4th person, basically. Okay, so where does the randomness come in? Okay, so we're going to select every 4th person. We have us all lined up, but where do we start? Well, that's where the randomness comes in. We're going to use a random number to select our first person in the line. And then after that, we get every 4th person. Okay, so we're going to choose, we want the first person to be in the first 4 on the list. Right, so I'm going to go back to the random number generator, and we're going to choose a number between 1 and 4. Okay, so I'm going to hit enter here, and we're going to start with the 3rd person on the list. Okay, it looks like we've lost somebody here. So hopefully this will still work. It looks like somebody just left. So, okay, we're going to start at the 3rd person. Okay, so let's see. 1st, 2nd, 3rd, Laura. Okay, so Laura, you are in our next sample here. Okay, so Laura. Okay, then we're going to do every 4th person from there. So that was randomly selected, right? So we do have a random selection there. We have some randomness introduced, right? So we have Laura. Then we're going to do every 4th person. Okay, so if it's every other person, if it's every 2nd person, we skip 1. If it's every 3rd person, we skip 2. So if it's every 4th person, we're going to skip 3. Does that make sense? So we're going to skip Julia, Crystal, Carlina, and then Brock makes it into our next sample. Then we're going to skip 3 more. 1, we're going to skip me, Shoshana, and Armand. And we're going to choose Devin. Okay, then we're going to skip 3 more people. 1, 2, 3, and we get Jennifer. See how that works? Okay, so we have our last sample here. Okay, and it's a perfectly valid, randomly selected sample. So Laura, Brock, Devin, Jennifer. What do you guys think? Any questions here about the 5 different sampling techniques? It's not rocket science, but it does require some attention to detail and some effort. And with these 4 different sampling techniques, you really can address quite a lot. I mean, even with unusual different kinds of populations, you really can do quite a lot of useful sampling. So I want you guys to practice with this. Here we have about 7 or 8 scenarios. And so each one of these is a sample that was done. And I want you to tell me what kind it was. Okay, so there are 7 different kinds of samples we discussed. Okay, and 2 of these are not good ones, right? 2 of them are ones we want to avoid. So I want you to put an X by the ones that we want to avoid. And then, yeah, so I'm going to go quiet. We don't have a ton of time, but I think we have enough time to finish this. And that'll get us to where we need to be for today. So I'll go quiet for a couple minutes, let you guys finish this, and then we'll come back together and talk about it. Okay, so Devin's asking about 1.3 with the overview of data collection principles. Let me show you that. So hopefully you guys have this page 10 exercise on your computers. And then, so is this the one you wanted, Devin? Oh, sorry, Devin. Is this the one you wanted right here? Okay, let's finish this off and then we'll be done for the week. Who can tell me this first one? We got the fifth person exiting the student center and every 12th person afterward is interviewed. What do you guys think?
See?
It is C. Great. This is systematic. That's the one we just did, right? Good. Um, so you randomly select a starting point, and then you've got people in a row, either physically lined up in a row or like names on a list. Okay, then 2 out of the 6 parking lots on campus are randomly selected, and every driver in the 2 lots receives a questionnaire. Anybody get this one? D. Good. So systematic is good. Cluster is good. We'll put stars next to those. Each registered student is assigned a number. 20 numbers are randomly generated, and the corresponding students are interviewed. What do you guys think about this? A, yep, that's the simple random. That's a really nice method. It's easy if you have a list of people in the population, which we do when it comes to students. Okay, so 6 buildings on campus are randomly selected, and every 4th person who exits each building is included in the sample. What do you guys think? Great, Crystal, this is correct. So yeah, it's the multi-stage. Okay, every person who smiles at the interviewer as he walks through the student center is interviewed. What do you guys think there? Oh, interesting. I was going more for a convenience sample here. Yeah, I was going for E on this one. It's easy to talk to people who are approachable, right? And who look like they want to talk to you. It's not so easy to talk to people who aren't, right? So that would be more of a convenient sample. Okay, so then you randomly select 10 student athletes and 10 non-student athletes who use the activity center to be interviewed. What do you guys think about this one? B, yep. Yeah, you're either a student athlete or you're not typically, right? And then so those are like strata. And then we randomly select from each one. Okay, and then the last one, this is a voluntary response sample. They're left on a table, and then they're questionnaires. So who completes these questionnaires? Well, probably people who are angry, mostly, right? uh, if you go to the library and everything's fine and you're satisfied, you're probably not going to do a questionnaire unless you're a really nice person, I guess. Um, if you're super happy, you might, but I think those tend to be kind of done by people who are not happy. I could be wrong on that, but either way, it is a voluntary response, right? The people weren't chosen, they weren't randomly selected, right? They were kind of choosing themselves. Okay, last point I want to make for your formula card, what I recommend doing, since you have a formula card, is why not just put a picture here of each of these on your formula card, right? So you guys know how to do these, like the snipping tool, right? And so it's a nice little piece of software. And then on your formula card for the exam, you can just put that in there, and then you got it right here, right? So anyway, just an idea for the first exam. Okay, we're out of time. We're past time, so I'm going to sign off now. Are there any questions as we break for the week? We'll be back on Tuesday. I had a couple of emails from people with difficulty getting the Kaltura video to work. So, so that might be something on my side that I need to change some kind of setting. So for now, if you can't get the Kaltura video to upload, just kind of put that on pause, and I'll work on it later and try to get that working. But for now, just do your introduction, and you can skip the Kaltura video for right now because it looks like maybe some setting wasn't set up correctly on my side. So any last questions? Anything you'd like to talk about real quick here? Okay, well, have a good day. See you guys on Tuesday. Thank you.
Thank you.
Thank you.